Dear students, greetings from Dr. T. Sendil Murugan, Associate Professor in Head Department of Information Technology, Faculty and Staff Technology and Science, Warangal. In this video lecture, we are going to discuss about implement the stack and queue using linked list. In previous lectures, while we are discussing the array concept, we implemented stack and queue using array. So in this video lecture, we are going to discuss about implement the stack and queue using linked list. This video is week 10, lecture 3, classroom discussion topic 30. We are going to discuss about linked stack and linked queue. That means stack and queue implemented using linked list. So, lecture outcome of this particular lecture is, after completion of this lecture, students will be able to develop a C program to create linked stack and linked queue with insert and delete operation. So what is linked stack? The linked stack, every node has two parts. So already we know, we already discussed about singly linked list. So in singly linked list, all the nodes have two portions. The first portion have the data value of the particular node. The second portion is pointing to the next node which is connected to the list. There is a start pointer or head pointer is pointing to the first node. So here, when we are implementing the stack concept, we have to use the pointer as top. So whenever we will insert or delete, we will perform in the stack, we must be use the pointer which we are given as top. The top equal to null means there is no node. Okay, so the top pointer is not pointing to any node means that is null. That means there is no node. So the entire stack is empty. Okay, so if you want to insert the element, it is possible, but if you want to delete the element, it is not possible because there is no node in the stack. So this is the diagrammatic representation. It's like simply linked list. This singly linked list have start pointer normally, but when we are using the stack, the top pointer is pointing to this node. So when we are thinking about stack, it is following the last in first out order. So whenever we want to insert or delete the node, that will be performed in the top position only. We know stack operations like push operation, pop operation, and pick operation. Push operation will perform the insert the node in the top position. Pop operation will remove the node in the top position, and pick, it will represent the topmost value of the stack. So based on that, we will see that operations, push operations. If you want to insert the node 9, in case the new node with the value of 9, then we have to check first top equal to null or not. If top equal to null means it's the empty list, that node will be the first node. So we will create the new node and store the data part as 9 and pointer part as null. So then top pointer is pointing to the new node. Okay. So if it is not null, then we have to think about list. Some nodes are there. Then how we will do that? So we know that insert operation in the singly linked list at the beginning position. The same we have to perform it. Okay. So we have to create the new node and data portion we will give the values and find the portion equal to top we can assign, then new node equal to top equal to new node. Like that we can perform. This is the algorithm. So first step we will check the memory, then we will create the new node. After create the new node of data portion is we will give the values. Then we have to check the top equal to null or not. If null means new node is the first node, so new node of next portion is null. So the top will point into the new node. Okay. So if it is not null, else means Then what we have to do, new node of next position is top, where the top pointer is pointing to the node. Then top will be changed to the new node. So this is insert operation. So same thing, coding also I given here. You just see we can create the structure of stack operation with push function. So we will get the topmost value of the stack as well as value which value we will insert, that is also will get it. Okay. So this top pointer is pointing to the location of the first position in the linked list. So we have to create one pointer. This pointer, for the pointer, we will create the memory. So after creating using ml function, we will create the memory. We know that already. After using this statement, the node is created and the pointer will get some value. So that is new node of new node. Instead of new node, we are using here PTR. The PTR into data, it means the data portion of the new node is equal to value. If top equal to null, again we will check. If null means pointer tends to next. That means new node of next portion equal to null, and the top pointer pointing to the new node. Okay, else. So there is some nodes are there. Then simply the new node to tends next equal to where the top is pointing. That value is pointing it. Then we will change the top pointer to new node. Okay, return top value. So now by whenever we will do the push operation, we will perform with the top position only. Okay. So pop operation, same thing. We have to remove the element in the top position only. So again, we have to check top equal to null or not. If null means what we will do, we are unable to delete it because it is empty. Okay. Otherwise, we can delete the element. How we will do? Top equal to top next. So that means where the top next is pointing means second node. Okay, so top will point into the second node and free the top if you are given, then free top, then top equal to top next. If you are given, that will be working. So see here, we will check the null pointer, then underflow will print, otherwise we will create one pointer, that pointer will point to the top position now, then top will change it to top next, that is second node. So then free the pointer which is pointing to the first node. So now first node is removed. So for that code we are given here, there is a pop operation. We'll create one pointer. That pointer will point into the top position now. So now in this statement, after this statement, we have two pointer for pointing to the first node. One is top, another one is PTR. Okay. So now what we will do? Top equal to top next. If top equal to null means we can simply print stack underflow. Otherwise, top equal to top next. So here this is the top node. Top next is second node. So we want to remove this node. So what we will do? Top will pointing to here. So this top next is pointing to here no. So top equal to top next means this top will move to here. So now PTR is pointing here. So free PTR if you are written means this node will be removed. Okay, free PTR means this node is removed. So next we have to discuss about the linked queue. Okay, so the previous examples of how pop and push operations are used. So here again, when we are thinking about the queue, we perform insert and delete operation. Okay, that is the DQ and NQ operations. We know already we have discussed about queue implementation using array. So in that front and rear pointer is there. So normally in array, so we are using front pointer is used to remove the elements, rear pointer is used to insert the element because it is following the first come first serve basis. So which node is comes first, that will be removed first. In this basis, we can remove. So based on that, if we are following this the linked list, so we can insert the list at the end position and we can delete the node at the front position. So already in single linked list, we have discussed about insert at the beginning, insert after the node, insert before the node, insert end of the list. Like that, these topics are we have discussed. So instead of their front and rear, same point we will use here, there. What we have to do, if you want to insert means definitely we will insert at the rear position only. So how we will do that rear position? The rear position will forward to null. So rear equal to rear next. We can perform this operation till reach the null pointer. If you are doing this while loop operation means the rear pointer is always pointing to the last node. The front pointer is pointing to front node. If you want to insert the node at that linked queue means the rear position will pointing it. Rear rear of rear next is pointing already it's a null pointer. When we are using that insert operation, we have to create the new node and rear of next portion equal to new node and new node equal to rear. So rear pointer equal to new node if you are assigned, it is pointing to last node. It is insert operation. Okay. So here rear pointer only we have to consider. We have to create the new node. So initially we have to check front equal to null means it is what is the meaning of that? There is no node. It is empty queue. So if that it is empty queue means it is the first node we are creating for the front and rear pointer is pointing to the same node. Okay. So front next the front node of next portion or rear node of next portion equal to null because it is the first node. So if there is no already nodes are there means what we will do? We will add to rear next equal to PTR, then rear equal to PTR. PTR means new node. Okay. So the new node will assign to rear position. Rear next is new node of next position is null pointer. So this is insert operation in the linked queue. To see the code again, we use this PTR. This is called like new node creation. So once the memory is allocated means the new node is created. New node of data portion equal to value. Whatever value we are given that will be assigned to new node of data portion. So here what we are doing that the queue of front portion equal to null we are checking. Okay. The q tends to front portion is null means q tends to front equal to PTR. Q tends to rear equal to PTR initially. Okay. So we have to create one pointer. That pointer of front portion and pointer of rear portion initially pointer. And q front of next portion equal to q rear of next portion equal to null. Okay. So where it is when we are inserted the first node. Or if already nodes are there means q tends to rear of. Why? Because we are getting the q value. In that position, we will do that operation. Okay. So how we will do that operation? If the q tends to rear of next node equal to PTR, q tends to rear of equal to PTR. That's a new node. Okay. So then after changing this, it is showing that then q tends to rear of next node equal to that is meaning of new node of next position is null because it is added into the last position. Okay, return q. So delete operation of linked queue. So we have to check front equal to null. Front equal to null means it's the empty list. We are unable to delete it. Otherwise, we can delete the element. What delete the element? Front equal to front plus one. So normally we are used in the array. But here what we will do? Front is pointing to the first node. So front we can create one pointer that pointing to the first node that PTR may be. So then front equal to front next. So that means it's a second node it will pointing. First node is already pointing to PTR. We can remove the PTR. So here both queue linked stack and linked queue delete operation is same, but the insert operation is different. While we are thinking about linked stack, it will be inserted into the beginning, but here in the queue we can insert at the rear position. So that's the main difference for insert and delete operation of linked stack and queue. So now it's a time for reflections part. So you have to read this line. If the linked list part, we will fill this line. So initially, if you want to delete the node on the first portion, how it will be work? So what is the answer? It's a time to answer it. Just see what is the answer. So you will take time to fill it. 10 seconds I will give. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Our time is over. So I hope you have written the correct answer. Otherwise, you can watch the video, go back and watch the video once again and answer the question. So I'll give the correct answer once we'll check with your answer. Okay. So this would also prepare Denson is the correct answer for both the dash places. If you have written the correct answer, you can proceed further. Otherwise, go back and watch the video once again. So we have discussed about actually we have discussed about stack and linked queue with examples and operations with the programs also. So based on the discussion, you can create the linked stack and linked queue. Then we will perform this. If further doubts, you can uh, refer Rimataraja textbook in chapter 6. Thank you all for listening this video. If further doubts, you can come to class. We will discuss in the classroom discussion. Thank you all.